Hello, I'm Caroline.
And I'm Abby, and this is our Phase 3 for the final CS 2316 project. In this presentation, we're going to discuss the relationships between Atlanta crime, location, and education levels.
Throughout this presentation, we will introduce our topic, discuss our data cleaning methods and reasonings, the insights we were able to draw from this data, and the visuals we created that support our insights.
We decided to look up the crime rates and incidents in Atlanta with the goal of gaining insight on crime in each neighborhood of Atlanta, to look at the correlations between the location and the crime, and also look at the correlation between the level of education and the crime.
We chose 4 main data sets to gather information from. We have 2 CSV files, one dealing with crime incident reporting for the year 2021, and the other showing the progression of high school graduates in Georgia schools. The next 2 data sets are an API that lists the type of crime and specific incident reports across Atlanta and in its metro area, and an HTML that we web scraped to show the populations of different neighborhoods across Atlanta. Now we'll move on to how we clean these data sets.
Our first main CSV file was the Atlanta Crime Report for 2021. First, we noticed that some of the rows had NaN values and we wanted to change them. We handled this by filling the NaN values with not reported so that these are not calculated when we're coding for our insights later on. Some of the ad addresses also had \n and other white space, so we replaced them so we could have a more precise location for the neighborhood when grouping our location clusters. Lastly, we renamed the column so that during our insight coding, it's easier to read and also is easier when grouping for our visuals.
We web scraped an HTML for our second data set. First, the column names had extra information that we didn't need. To be more concise, we renamed them to match our other data sets so that we can match values across multiple data sets when drawing our insights. Second, some columns had NaN values, like our first data set. To combat this, we also filled the NaN values with not reported so that these values are not calculated when finding our insights.
Our third dataset is the API of the crime type and count of Atlanta and its metro area. Like the others, the columns didn't match, so we renamed them so that we can match information across multiple datasets. Again, like the others, some of the columns had NaN values. We dropped these rows so they're not calculated later and does not skew the data. We also reset the indices to include the neighborhood instead of just numbers, so that way we can access the data easier using the .loc function instead of the .iloc function. Lastly, we rewrote the date column to just include the year and created a new column accordingly so we can see the trends across each neighborhood.
Finally, we included one extra source in the CSV file that discusses the progression of high school graduates across the entire state of Georgia. First, the columns did not match the rest of our data, so we renamed them to be more consistent with our information across data sets and to properly apply them for our visuals. Second, the CSV also contained data for other schools in all of the counties of Georgia. With masking, the CSV now only shows students of Atlanta public schools, specifically the graduating class of 2007, and the proportion of this class that had earned a post-secondary credential by the year 2019. Lastly, we reset the indices of the data frame to be the names of the schools so we can cluster them together when coding through our insights.
Now moving on to our insights. For the first insight, we wanted to find the crime rates for each neighborhood in Atlanta. Using this data, we can draw conclusions about which neighborhoods are the safest based on the total crimes committed divided by the population of the neighborhood. To do this, we combined the population and crime data frames. We grouped by the neighborhood. We counted each row as a crime committed within that neighborhood. We dropped any invalid rows, and we renamed the columns and created rows to show the total crimes committed per neighborhood and total crime per capita.
To build off the crime rates per neighborhood, we have grouped each neighborhood into a location cluster, north, south, east, and west. We want to determine what area of Atlanta houses the greatest proportion of total Atlanta crime and which sector of the city is safest to be in strictly with these statistics. First, we designated which sector of Atlanta each neighborhood fell in, using cutoffs of I-75, I-85, and I-20 on a map. Then, we found the total number of crimes per sector by grouping neighborhoods and then using for loops to count. Lastly, we divided each sector total by the Atlanta total and added that column to the data frame.
For Insight 3, we wanted to see if there was a correlation between education level and crime rates in different areas. We assumed that we would find a correlation, but after coding, we actually found that there was no real correlation between education level and the crime rate of a specific area. We did this by using the same sector groups as we used in Insight 2, and we created counts of crime for each sector. We then grouped inner Atlanta public high schools by the same boundaries. We divided each count by Atlanta total and counted the amount of high school graduates in the class of 2007 that earned a post-secondary degree by 2019 for each high school in the sectors. We then created rows for each percentage to show the data.
For Insight 4, we wanted to compare the rate of change of violent and property crime from 2014 to 2016. We have also separated the areas into groups based on whether or not they are inside or outside the Atlanta perimeter. We expect to find a greater rate of change for the areas inside the perimeter. Similar to what we did for Insights 2 and 3, we designated whether cities were inside or outside the perimeter using I-285 as a cutoff and added a column at the end of the data frame stating inside or outside. Then, using for loops, we counted the total amount of crime for 2014 and 2016 for each city. Then, finally, we calculated the relative change for each city from 2014 to 2016 and added a column stating so on the data frame.
For our last insight, we wanted to calculate the total of each type of crime and look at its proportion to the total crimes committed. This way, we can analyze what type of crime are committed the most. From this data, you can see which type of crime is the biggest problem and what needs to be tackled the most.
And finally, we will discuss our visuals that we created to support our insights. For Visual 1, we created a bar chart. This bar chart shows and compares the crime per capita rate in each city using the data frame from Insight 1. From this chart, the bars that are tallest have the most crimes committed per person, and the shortest bars have the least crimes per person. By choosing a bar chart, it is easier to visualize how each neighborhood compares to each other instead of to the total.
For our second visual, we used a pie chart to show how each sector of Atlanta compares to the total amount of crime committed in the city using the data frame from Insight 2. Using the pie chart, you can see how each sector, north, south, east, and west, contributes to the total number of crimes committed in Atlanta.
Our Insight 3 was trying to see if there was a correlation between education and crime. With this double bar chart, we are able to compare how the graduation progression of high schools in each sector compared to their crime rate. With these specific data sets, we did not find a correlation, as one can see in the bar chart.
We wanted to use one extra visual to show the statistical layout of the relative change of crime numbers from 2014 to 2016. Through these box and whisker plots, we are also able to compare how the cities inside the perimeter compare to those outside the perimeter. As you can see, the cities on the inside had a greater decrease in crime rates, whereas the ones on the outside stayed relatively consistent through these years, which supports our claim from Insight 4.
Overall, using the specific data sets that we did not witness any true correlations between certain variables. Our information did not support the initial impressions that we both had going into this.
Through this project, we have learned so many new things outside of class instruction. We've learned how to code into more kinds of charts, for example, a double bar chart, and how to convert data types more easily than before. We also learned how to manipulate data sets for real-world application, something that we hadn't really done before.
The greatest challenge for our team was finding the right data sets that both supported what we wanted to find and that we could draw correlations between.
We have learned so much from this project throughout the semester. Both of our coding skills have gotten exponentially better than where we started. We both feel more confident with data manipulation thanks to this project. Thanks.